Welcome to the channel. Today we're tackling a question straight out of science fiction. Is it possible to travel to Mars right now? And what challenges would we face once we get there? Buckle up as we dive into the scientific reality of traveling to the Red Planet.
After spending more than a year living in conditions designed to simulate those on Mars.
The Mars venture, I think, is part of the expansion of consciousness beyond Earth.
I am so proud and honored to be part of this crew and project, and to be a part of a small incremental part of the work being done here on Earth that will one day enable humans to explore and live on Mars.
Phase 1. Current possibilities. First off, let's address the big question. Can we travel to Mars right now? As of 2024, the short answer is no. But we're closer than ever before. Organizations like NASA, SpaceX, and international space agencies are working tirelessly to make Mars travel a reality. NASA's Artemis program aims to return humans to the Moon by 2024 as a stepping stone for Mars missions. SpaceX's Starship, designed by Elon Musk, is ambitiously targeting a crewed mission to Mars in the 2030s. The technology is advancing rapidly, but several challenges still need to be addressed before we can send humans to Mars safely. Phase 2. The journey to Mars. Traveling to Mars isn't like a road trip to the next town. It's an interplanetary journey. Mars is an average of 225 million kilometers from Earth, and depending on the alignment of our planets, it could take anywhere from 6 to 9 months to get there using current propulsion technology. This duration presents significant challenges, both technical and human. Radiation exposure. Space is filled with cosmic radiation and solar particles. Without the Earth's magnetic field to protect them, astronauts would be exposed to high levels of radiation during the trip. This could increase the risk of cancer and other health issues. NASA is researching protective shielding and pharmaceuticals that could mitigate these risks. Psychological challenges. Spending months confined in a small spacecraft with limited social interaction can take a toll on mental health. Astronauts would need to cope with isolation, monotony, and the stress of living in a hostile environment. NASA conducts psychological testing and training to prepare astronauts for these conditions, and ongoing support would be crucial during the mission. Phase 3. Landing on Mars. Assuming we make it to Mars, landing on the Red Planet is no small feat. Mars has a thin atmosphere, about 1% as dense as Earth's. This makes it difficult to slow down a spacecraft during descent. NASA's Perseverance rover, which landed in 2021, used a combination of heat shields, parachutes, and rockets to touch down safely. For human missions, we'll need more robust systems to land larger payloads. Phase 4. Surviving on Mars. Once on Mars, the challenges continue. The Martian environment is harsh and unforgiving. Here are some of the biggest obstacles we'd face. Extreme temperatures. Mars is cold, with average surface temperatures around -80 degrees Fahrenheit, -60 degrees Celsius. Spacesuits and habitats must be well insulated and heated to keep astronauts warm. Thin atmosphere. The thin atmosphere offers little protection from cosmic radiation and is mostly carbon dioxide. We'd need advanced life support systems to provide breathable air and protect from radiation. Water scarcity. While there is ice on Mars, liquid water is scarce. Extracting water from the soil or ice and recycling wastewater will be critical for survival. NASA's MOXIE experiment is working on generating oxygen from the Martian atmosphere, which is a step toward sustainability. Food supply. Astronauts would need a sustainable food supply. Transporting enough food for a multi-year mission is impractical, so growing food on Mars is a necessity. Research is ongoing into hydroponics and other methods of growing plants in Martian soil. Dust storms. Mars is known for its massive dust storms, which can last for weeks and cover the entire planet. These storms can reduce solar power generation and pose a threat to equipment and habitats. Phase 5. Building a Martian habitat. To live on Mars, we'd need habitats that can protect us from the extreme conditions. These habitats would need to be airtight, insulated, and capable of producing oxygen and recycling water. Some proposed ideas include inflatable modules, 3D printed structures using Martian soil, and underground habitats to shield from radiation. Phase 6. Long-term sustainability. For long-term survival and potential colonization, we must think about sustainability. This includes generating power, most likely through solar panels or nuclear reactors, recycling waste, and building infrastructure with local materials. The goal is to create a self-sustaining colony that doesn't rely on constant resupply missions from Earth. Phase 7. The human aspect. Finally, the human aspect of living on Mars is perhaps the most challenging. Adaptation to lower gravity, ensuring mental well-being, and building a cohesive society in a new world are monumental tasks. But with the spirit of exploration and the drive to push our boundaries, humans could one day thrive on Mars. So can we travel to Mars right now? Not yet, but we're on the path. The challenges are immense, but so are the rewards. Mars represents the next giant leap for humanity, a chance to explore a new world and expand our horizons. Thanks for watching. If you enjoyed this video, give it a thumbs up and subscribe for more space content. Leave a comment below with your thoughts on Mars exploration. Until next time, keep looking up.